right, let's tackle some of the problems that we don't have to graph, and they're actually going to be a little less cumbersome because there's not as much to draw. So here goes, and they're actually just as easy as they look. So let's just take it one component at a time. And when I say component, I'm really looking at first number, first number, first number. So -4 plus 4, 0. So 0 minus 9, no secrets there, that would be a -9. So there we go. That wasn't too hard. However, the only catch to this is it's easy to overlook the signs. Like this time I'm subtracting and we might get in a habit of adding, so just be careful. So then we'll do the same thing here. We'll be like 5 plus 8, you know, no big deal, that's 13. 13 minus the 7, so watch your signs. 13 minus the 7, so that one's gonna be 6. So not hard at all, we just need to be careful. There's a lot of computational errors that we could make. Before we start the next problem, I recommend that we distribute. So let's take this 1/4 and multiply by 16. 1/4 times -12. We'll do that first. So 1/4 of 16 is 4. 1/4 of 12 is 3, but the signs are different, so there we go. And there's nothing here to distribute. So there's that. And now it's just a straightforward problem where we just go 4 plus 1, and again, no surprises there. It's that easy, I promise. And then -3 plus 1. So the math itself is super easy. You're just adding and subtracting and multiplying, and maybe a little division from time to time with things like 1/4. But the whole point is that it really represents something different. It represents like the trajectory of something. And so just because of its representation, it's really practical, but the math itself is not hard. All right, last problem on this side. Let's do 2 times that, 2 times that, and -8 times that, -8 times that. Here's a personal preference of mine. What I like to do is, if that's subtracting something, I like to call it plus a negative. That's kind of middle schoolish, but it does cut down on a lot of computational errors. So far, what we have is 0, 1, which didn't change at all. And then 2 times that, so -8. 2 times 8 is 16. And then plus -8 times 1, -8, -8 times 1, -8 again. And again, the math is not that hard. It's just a lot of steps, and we have to be careful. So 0 plus -8 plus -8. So really -8 minus 8 is -16. And then 1 plus 16 minus 8. That, I believe, would be 9. There we go. All right, we're going to flip the paper over. And it's the same type of problem on the back, only they're represented a little bit differently. Again, so slightly different representation. And what happened was they gave us 2 different vectors, and this one was u, that one was v, and now they want us to do this stuff given what they've already defined up here. So let's do it. It's not going to be hard. -u plus 1/2 v. So -u, so 4, 5, plus 1/2 of v, -6, 10, there's that. So we'll put that one there. And we're going to distribute -1 to 4, -4, -1 to the 5 is -5, and then we'll do the same thing here. 1/2 of 6 is 3. Technically it's -3. 1/2 of 10 is 5. So again, just don't make it harder than it is. -1 times 4, -1 times 5, 1/2 times this, 1/2 times that, and we're good to go. All right, -4 plus -3 is -7. -5 plus 5 is 0. There you go. All right, they don't get much harder than that, so why don't we go a little bit faster. This next one is v minus 4u. So just notice that the order is different. So v was the second one, but now it's first in the problem. So here's v minus 4 times u. There we go. And personal opinion, I think we should start by taking this -4 and distributing that. So we'll do that, and we'll do that. So -6, 10, plus, all right, -4 times 4, that's going to give me -16. -4 times 5 is going to give me -20. And now we just do the basic math. So you got this. Feel free to mute the video and do it on your own. -6 minus 16, -6 minus 16 is -22. And then 10 plus -20 is -10. There it goes. All right, 100u plus v, and let's actually compare it with this one, 100u plus v, and there's a difference in my tone of voice, but there's a difference in what's being distributed and where it's being distributed to. Well, not a difference in what's being distributed, but there is a difference in where it's going. So this is 100u plus v. And then this one is 100. And then we'll just put some big parentheses here and we'll add u plus v. So 4, 5. Things get a little crazy with parentheses and the vector brackets. I'm having a hard time saying it. There we go. It's just a lot of stuff going on. But in this particular case, we have 100 times 4, 100 times 5. There's that. And then plus negative 6, 10. 400 minus 6, that would be 394. And then 500 plus 10, 510. So again, easy math. Lots of steps, but easy math. And in this case, you might be like, oh, 100 times that, 100 times that, 100 times that, 100 times that. You wouldn't be wrong, but let's not. Let's kind of hold off on that 100, and let's do the order of operations, which means parentheses first. So 4 plus negative 6, that'd be negative 2. 5 plus 10, 15. There we go. And now the parentheses are kind of useless at this point, but that's all right. 100 times that, 100 times that, and we are done.